you tried to reproduce scientific data and scientific results, and have you failed? Or do you know someone who tried to replicate scientific data and was not successful? To take out your iPads, you have a very time-limited time to finish, 30 seconds. So start. Okay, well, it's overwhelmingly obvious that you are aware of this issue. And it probably goes back quite a long time. In fact, it's become endemic in our scientific culture to expect that things just don't work. When Sir Isaac Newton said, "I can see so far because I stand on the shoulders of giants," he was saying that I work on the people who came previously. I have been able to work on what they have discovered and advance my findings. But I think over time, we've come to expect that things just don't work. It's become a part of our cultural norm. And data reproducibility issues are far more of a problem than we like to admit. I'll give you an example in my own experience. I was at lab in Novartis, and all great breakthroughs always start with working on someone else's work to try to use it as a baseline of your own work. And so what I saw was a couple of papers with scientists I actually knew about who published on work on small peptides that they could stabilize. And I went to my colleagues and I said, we have a compound archive that's 1.5 million. It takes $1 million to screen through this. What if I could build something that's 1 billion moieties, chemical moieties, and only cost you 10,000? Of course, everybody got excited, and I went straight to work to do that. I went to the research scientists who had published already. I got their cell lines, I got their peptides, the expression plasmids, and I put them together, and it didn't work. And then, of course, I tried to sequence that plasmid in case it was wrong, and it didn't work. I went to a colleague and said, look, I think I got bad results here. Could you synthesize this plasmid for me? And it didn't work. And we went to an expert outside, a vendor, who codon optimized those expression plasmids, and it still didn't work. Finally, we sequenced the strains, the cell strains that we had, and it didn't work. 2 years later, I had nothing to show for the data, a lot of frustration, a lot of money wasted. And typically, what happens in the lab is that you take these data and you throw it away, because the culture is that you reward it for things that work, not showing what doesn't work. But what I want to tell you is what actually came out of that. And the first thing I want to tell you is that this frustration that we had is basically endemic of something that's much bigger. And we've never quantified the issue of reproducibility before until a couple of landmark papers came out. And I want to tell you, only pharma could do this, because pharma has dedicated labs set up just to validate work that's already published. That's where we start our drug discovery projects from. And what was shown by Amgen and Bayer is that they looked at projects that started internally, and they followed them. They said which ones started from publications, and they followed them internally to see if they worked or not. And Amgen's results are clear: 53 landmark papers, and 90% were not replicatable. From Bayer, 67 oncology, cardiovascular, and women's health projects. And again, 50% were reproducible, 25% marginally, and 25% reproducible. That's not just for wet lab work. Dr. Ioannidis at Stanford, he looked at just primary data on microarrays and tried to use the algorithms that they did, that the authors used, and could not replicate 90% of these microarray studies. And so in my experience, what we wanted to say was that if you throw away your data, and you throw away those results, you become part of the problem. And we wanted to think of a different way that we could work with, that something positive could come out of our experience, and that we could maybe publish our lack of reproducibility and generate a discussion about how to make that actually work, because it would be phenomenal to have a 1 billion compound library. And so we generated a reproducibility report, but where do you publish it? So we said we couldn't find a place that actually you would be able to publish that's a reproducibility report. So we said, let's make one. Let's make a platform where we can publish these findings, which are focused primarily, the dialogue is focused on the reagents and the methods of measurement. It's not about finger pointing, about fraud or other things like that, but more a constructive dialogue and saying, let's try to make it work and crowdsource it a little bit. In fact, the very first thing you would do in this model is that you would talk to the original authors in a constructive way. They could feedback on you on reviews of what you tried to do in that replication report. And of course, many replication reports could be published on that. And look at what starts happening. When a paper is published in a high-end journal and very visible, labs all around the world start to replicate or try to reproduce those results. And if you replicated and already produced a reproducibility report, you'd save millions of dollars and millions of man-hours around the world. It could be phenomenal. It could be phenomenal. And so I got the 1 minute mark. And so, but this platform allows you to also, individuals who are working in the field to also talk to among themselves. And so we often use impact factor as a measure of quality. But what is the meaning of that when you can't actually replicate that data? It's completely useless. And what I want to move the audience to discuss is perhaps we can think about reproducibility factor as really a measure of quality of the science that we try to work with. So thank you very much.